Maybe. So check it out. Who can use their psychic powers and tell me what it is that we're learning about today? Solving absolute value equations. And before you are done, you will be able to solve an absolute value equation. And how are we going to do that?
Discussing potential solutions of an absolute value.
There it is. Beautiful, right? So, because sometimes people will walk in the classroom and they'll be spies, aka principals, and they'll say, "Hey, what are you guys doing today?" And you should never say, "Oh, no," because you can always just look up there and read it, right? That's called the objective. So that's what we're going to knock out today. So let's go ahead and title the notes: Solving Absolute Value Equations.
Somebody's looking.
Orange.
All right, solving absolute value equations. Now, before we get jumping in that, most of you, hopefully all of you, already know what absolute value means, right? So just in case you didn't, let's just throw a thought bubble in there. Here's absolute value. If I say absolute value of 5, we know the absolute value of 5 is 5. Of course, of course. If I say the absolute value of negative 5, we know that is 5. Of course. Absolute value technically means a number's distance from 0 on a number line. So if you think about a number line where 0 is sitting in the middle, negative 5 is over here, but if you count the hops it takes to get to 0, it'd be 5. 5 is sitting over here. If you count the hops it takes to get to 0, it's still 5. So absolute value is always positive. Now, so if I give you a real simple absolute value equation, like our warm-up, absolute value of x equals 5, you know the possibilities are either x equals 5 or x could be negative 5. Right there is the key of today's lesson. If you learned absolutely nothing else from me today, the one thing I need you to take away from this is when you're solving an absolute value equation, you should expect not one, but 2 solutions. It's not going to happen every time, but most of the time you can expect 2 solutions. And we're going to talk about when there's going to be 2, when there's going to be 1 or none as we go forward today, right? But if you learn nothing else today, go ahead and I like to make things important in boxes. So I'm going to say, I'm going to shorten this, AbsVal Equations, expect 2 solutions. And let's throw a little box on. Where's my magic box? There it is. Bam! So that's the key thing you got to take away from class today. All right, let's jump into an example. Let's say I gave you, and your job's going to be to solve this. Example 1. Solve. Okay, it's absolute value of 2x. Let's do minus 3. I need to make my eraser smaller. It's so clumsy. I'm going to adjust my settings. All right. Absolute value of 2x minus 3 equals 5. And we got to try to find out what x is. But there's a couple ways you can do this problem, right? You can do the old guess and check and just guess a bunch of numbers until you figure it out. Probably not the most efficient way to do it. Instead, let's use just a little bit of common sense here. Now, I would imagine if I gave you guys enough time, you could all figure out what the answer would be. But let's see if there is some sort of process that we can use. Think about it this way. You know that, let me see if I can come up with something here. Let's use, that looks about right. Technology. Let's do a cool pattern. So take this absolute value And let's just cover it up for right now. We know that whatever is behind that mystery symbol, let's call it a wall, I don't know. Whatever is behind this block could equal one of two things. It could either equal 5, or it could equal -5. Whatever is behind this block could equal 5, because the absolute value of 5 would be 5, or it could equal -5. Absolute value of -5 would also be 5. So, I say it again because it takes a while for people to actually get what I'm actually meaning here. Whatever is behind this block could either equal 5 or -5. If you can understand that, you're done. Because all you got to do is think about, okay, well, what was behind the block? 2x minus 3. We said it can either equal 5 or 2x minus 3 could equal -5. We just said whatever's behind this block could either equal 5 or it could equal -5. Well, what was behind the block? 2x minus 3. So all we got to do is set up two equations. One where 2x minus 3 equals 5, and the other one where 2x minus 3 equals -5. You can do that, you're 75% of the way there. Notice now I have two separate equations. But the equations don't have absolute values in them anymore. This is just straight up old school. That's just algebra 1 stuff. That's a 2-step. You can crank that out in your sleep. Do the first one. Add 3, you get 8. So then you end up with 2x equals 8. All right, for the viewers at home, just in case, I'll go ahead and do the first one step by step. You guys would know to add 3 to both sides, right? So then you end up with 2x equals 8. Then you got to get rid of the 2. Divide both sides by 2. Shazam. And x equals 4. Que fácil. That's half of it. Now you got to come over here. Same old thing. It's a 2-step equation. No absolute values now. So let's just go to work. How do I get rid of the -3? Add 3 both sides. And now you end up with 2x equals who? -2. Careful now. -5 plus 3. It's like owing somebody $5 and then someone gives you 3. You're still 2 in the hole, right? So then how do I get rid of that 2? Divide, no biggie. And the other solution is x equals -1. But bam! We took something that looked foreign to us when we started, and we broke it into something that was pretty straightforward. Alright, now, it's an equation, it's like anything else. If you want to check your work, how do you go about doing it? Substitute back where you started, right? So if you want to check, make sure you substitute. Now we can do that in our heads. This is a pretty basic problem, nothing too fancy. 4 goes in, 2 times 4 is 8, 8 minus 3 is 5, absolute value of 5 is 5, great. -1 goes in, 2 times -1 is -2, -2 minus 3, careful, -5, because it's like -2 plus -3, right? -5, absolute value of -5 is 5, okay, nice. So, you just solved an absolute value equation. The key thing here you got to remember is when you separate it into two different equations, you need to drop the absolute values, right? What I see some people do, and some of you guys are still going to do this because it happens every year. You know that these two guys, you know you're supposed to separate it into two, one that equals a positive, one that equals a negative. And then, but for whatever reason, they'll just keep these here. And then they want to do it again, and they'll do it again, and do it again. It's like, yo, stop. Easy. The whole idea behind separating it is that you don't need the absolute value signs anymore. All right, let's do another one. Ejemplos. Oh, sorry there. That's okay. Well, you know what? Let's go ahead. Sorry. Coming back to example 1 real quick. This one is kind of silly. Oh, what happened to my directions? Did it just say solve at some point in time? I wonder where that went.
Is it under the mystery box?
I don't think so. Alright, well, the direction said solve. The other thing that you're going to have to do next week is graph on a number line. Yeah, it's not bad at all. This is actually really, really simple. For these type of problems, for equations, it's actually kind of silly. But if you had to graph it on a number line, all you do is draw a line. You don't need to go buku and throw a bunch of numbers on here. Just throw the important ones. -1 and 4. That's all I really care about. You can fill in the other ones if you really want to. But for this one, all you got to do is put circles on those spots. That's it. It seems kind of silly. When you get to absolute value inequalities, you're going to see why we have to do things on a number line. But for right now, it's just the key points on the number. It's just those specific values, right? Now, the other thing that you're going to have to do down the road is express your answers in what's called set notation. You guys ever heard of that before? Set notation, you might have seen it in your geometry class. Set notation is just a fancy way of writing the answer. And for this particular problem, we know that x equals 4 or -1. Set notation just puts that in funky brackets. They put a little bracket there, and they say x, this straight line means such that. Mathematicians sometimes just make things more complicated than they need to be. It means x such that x equals -1 or 4. That's what's called set notation. You're going to see that a lot in pre-calculus and calculus when you get there. So it's nothing to freak out about. You just got to know what it means. X such that x equals -1 or 4. That's set notation. So get used to that, because you're going to be seeing a little bit more of that as we go forward. All right? Now let's do example 2. Sorry. And let's do 2 times absolute value of x minus 3 plus 4 equals 1. And same idea when you solve for x and all that good jazz. Take 7 seconds, and I want you to try to answer these 2 questions. Question number 1, how is this problem different from the first example? Bye-bye. Question number 2, what do you think is going to be the first step? Think about it, 7 seconds, don't tell me. Where did Victoria go? Unbelievable. Cornell. First question, how is this different from the first example? There's a 2 in front. Anything else make it different? And you got a 4 after. So this one, before the absolute value was kind of all by itself, and this time you got a 2 and a 4 in the way. Fair enough. What do you think will be the first step? How am I going to solve this? Can we do it exactly like we did the last one? Anyone got an idea? What do you think the first step is going to be? What do you think, Daniel?
Yeah, I think we want to distribute it so that we can make it like the last one.
Distribute it?
Yeah.
Maybe. What do you think, Madison?
Take the S out.
Take it out? What are you going to do? Take it out? Gone? What are you going to do?
Like, take it and equal it to 1.
So somehow get this kind of by itself so that it equals, oh, okay, maybe, I don't know. What do you think, Jocelyn, right? Did I make that up? That's not right. Mary.
You, no.
Never make sure? I mean, I don't know. Let me tell you what you're not going to do. It is not okay to split it up into two equations yet. Okay? Right now, the way it stands, very common mistake. People will say, oh, whoops. What I'm doing is wrong, so don't write this down. They'll say it equals 1, and then they'll say that. Because that's what we did last time. The problem is, we haven't set up our mystery box yet. This isn't saying that this whole thing either equals 1 or negative 1. We know that whatever is in here could have two different possibilities, but that doesn't apply to the 2 and the 4. So the first thing we got to do, we got to make example 2 look like example 1. And that's kind of like what Madison was saying. Now, in order to do that, here's a little thought bubble for you. Treat that as a mystery box again. We don't know what's behind there, so here's a little thought bubble. I like to do my thought bubbles in green. Pretend this thing said 2x plus 4 equals 1. Same idea, right? I don't know what x is yet. I don't know what's behind the mystery box. Same idea. What would you do to get x by itself? Subtract the 4 and then divide by 2. So what do you think we're going to do over here? Subtract the 4 and divide by 2. Same idea. And I'll go ahead and fill it. So here's my little thought bubble. Over here you subtract 4, and then you would have 2x equals negative 3, and you divide by 2. So then you would have x by itself. We'll do the same thing over here. Notice what I did not do. Did not distribute. This time, it looks so tempting. So tempting. This time, it actually wouldn't make a difference. But the next example I give you, will make a difference. So don't distribute in absolute values. We're going to emphasize that later. But right now, so here I'm going to subtract the 4. So then I end up with 2 times the absolute value of, what was behind there? X minus 3. Equals negative 3, right? That's what I'm going to subtract 4 from both sides. Then you got to divide by 2. So you end up with the absolute value of x minus 3 equals negative 3 halves. Oh my God, there's another fraction! What am I going to do? Man! Remember that time I said you got to get used to working with fractions? It's my goal. I'm going to put a fraction on every test. Because you got to get good with it. I mean, you can't be scared of fractions. You guys are supposed to be the cream of the crop here at Freedom. You can't tell me you can't deal with a fraction. Now, if you don't remember how, it's okay. We just got to fix it. And I don't have time to do it in class, but I suggest just go on Google and just look up fun fraction practice. And I'm sure there's some cool game. If you go on, like I said, if you go on our website, there's a link there that says like helpful math websites or something like that. And click on that. There's one that says like basic computational skills or something like that. There's like some fun games that you can do just to practice your fractions, right? You guys can get it in no time. It just takes a little bit of practice. So over the weekend when you have a chance, you're sitting at the bus stop, got your phone out, whatever, if you got Wi-Fi, just play games, practice your fractions. All right. So now, even though it's a fraction, this looks like example 1, right? So, except one thing. There's a trick here, and I didn't mean to do this. I'm such a jerk. I didn't mean to do this, but it's fine. It'll work out. I didn't mean to give you 2 things that are happening at once. You guys see why this problem is still different?
Just gotta do something else.
Sort of. Yeah, it actually equals a negative. Remember what we said about absolute value?
Yeah.
It's always positive. No matter what x is, when it goes in, you can make it 1 million, you can make it negative 1 million, you can make it 24,000, whatever. Subtract 3 from it, sure. when you take the absolute value of it, that's always going to end up being positive. I will give all the money in my bank account, which isn't much because I'm a teacher, but I'll give you all the money I have if you can give me a number for x that when you plug it in here and take the absolute value of it, you get negative 3/2. Wait, you said negative 2?
Yeah.
Negative 2 goes in, negative 2 minus 3 is negative 5. Absolute value of negative 5 is positive 5, not a negative. What's up, Dave? No. Well, you can if you want, but not right now.
It's a decimal. It's the whole number.
Would I offer up all my money if it could actually be done?
That's why Mr. Kill can do it.
Can't do it. There's no value of x that you can plug in here. Then when you take the absolute value, you're going to get a negative. It just can't happen. So the answer to this problem is that there is no solution. So here what I would write to yourselves is that absolute value cannot equal a negative. So this one is actually a little easier than the last problem because you don't need to go any further. You don't need to separate it into two different equations. You can stop right here. Absolute value can't equal a negative, so the answer is no solution. And sometimes you'll see this little symbol. That means no solution. It's 0 with a line through it. No solution. Man, I did not mean to give you that. I wanted to say that for example 3. But you got it. So most of the time when you do an absolute value equation, you can expect there to be two solutions. But every now and then you're going to run into a situation where there's no solution. And you could probably ponder there's going to be a time down the road where you're going to get one solution. Let's see if I can do that right. Where's my, where's my, oh, yes. Alright, so let me try, okay, let me see if I can do this. So let's do example 3. Oops. Are you serious? Alright, last one. Now I want to do some practice problems. Alright, let's do absolute value of half of x minus 3
There's only one solution.
equals negative 2x plus 10. This should work.
Why?
Alright. So we got here, this is 11:50, so, oh, man, I got plenty of time. Alright, so if I screw this up, we'll try again. Okay, absolute value by itself, good to go? Sure? This time there's nothing over here distracting us, we don't need to like add or subtract another number over there. Right? So, we don't need to divide anybody over here, so let's just go to work, and we got that whole mystery box thing. Where's my mystery box? There it is. So, what's behind the mystery box could either equal negative 2x plus 10. Sure. So we said it was 1/2 x minus 3. It could equal that. Or what's behind that mystery box could equal negative that.
So,
Right?
Negative.
If you take it one step at a time, you're right. It's going to end up being 2x minus 10. So whoops, hold on, I didn't write the rest of it. 1 half x minus 3 equals negative all of this, which is really saying 2x minus 3. Alright, well that's algebra 1 stuff. Yeah, it's got a fraction in it. You guys solve it, I'll meet you at the finish line. Alright, Francisca, break it down for us. What did you do first?
So I added three to both sides.
Sure. And then what'd you get?
Then I ended up with 1 half x equals negative 2x plus 13.
Mm-hmm.
Then I added 2x to both sides.
That sounds great.
And ended up with 5 halves x equals 13.
Oh, we might need a thought bubble there. I think we might have lost some people. 1 half plus 2. 2 is like 2 over 1. So don't go and do 1 plus 2 just yet. Got to get the common denominator. 2 over 1 is the same as 4 over 2. So then 1 half plus 4 halves is 5 halves. So some of us might have gotten tripped up there.
So it makes the
Fractions 101, y'all. Get with it.
Hey, Mr. Tucker, I bet you need that's 2 and 2.5.
You gotta get used. This is gonna be much easier down the road. What did you do next, Francisca?
And then I just multiplied by 2 over 5 and both sides.
Sure. Multiply by 2 or 5. If you don't like multiplying by fractions, by the way, you multiply by the inverse. You could also say that, right? Is you can multiply by 2 first to get to 26, and then divide by 5. Either way, you're gonna get 26 over 5.
I did it.
All right, Francisca, not bad, not bad. Now we're gonna find out if that's a valid solution or not here in just a second. But right now, well done. For the sake of time, let's just walk through the second half of this together. On the right side, what's the first step? Just tell me, anybody.
Subtract 2x.
You can subtract the 2x if you want to, or you could add the 3. I'd probably add 3 first. And then, really, actually, I'll tell you what. I don't want anybody to think that what they did was wrong. At the end of the day, if you subtract the 1 half x from the 2 half, you should get 3 halves x over here, and then you're going to end up with 7 over here. Do whatever you do, you got to get there, right?
I got negative 3 and
Well, be careful. If you subtract 1 half x from 2x, right? Here's a little thought bubble. Here's 2 minus 1 half.
1 half minus 2.
Well, if you want to bring this over to the other side, then the 1 half is going to be negative. Oh, I'll tell you what. You might have had negative 3 halves and negative 7, right?
Yeah, I got negative 3 halves equal negative.
Yeah, same thing. Same thing, right? Because all you did is multiply both sides of the equation by negative 1, which you're allowed to do.
Makes sense.
So either one of those is fine. So now I got to get rid of this, the 3 halves, right? So multiply by 2/3, which ends up being
14.
14 over 3. So it looks like x equals 26 over 5 or 14 over 3. By the way, notice the x's don't have to be the same. They don't have to be opposites of each other. Think back to example 1 that we did. We found out x was 4, x was negative 1. They're not opposites. It's when you plug them in, they both work. Don't get lured into thinking that you're always going to have one that's positive and one that's negative. Sometimes one's positive, one's negative. Sometimes they can both be positive, they can both be negative. It really depends. The only thing you can expect is that there are 2 solutions. Now, I told you that sometimes there's 2. Most of the time there's 2. We just saw example 2 said there are no solutions. And we got example 3 when I was trying to give you one that was just one solution. But we did everything right, Mr. Tucker. We followed all your steps perfectly. At the end of the day, when you're done with absolute value equations, you always want to go back and check to make sure what you did was right. How do you check? Substitute. Let's see if we can do this in our heads. Fractions are a little tougher, but we might be able to get close. Tell you what, that other side, that's going to be a little tricky. Let's go ahead and just work it out. So, 26 over 5. The original problem said, now we're checking our work here. original problem said, what is it, 1/2 x minus 3, and it's supposed to equal negative 2x plus 10. I want to see if 26 over 5 works. Now, the nice thing about checking your work is sometimes you can be a little sneaky. You don't have to do all the math. Let's start on the right side. Negative 2 times 26 over 5. You guys buy that 26 over 5 is like 5 and some change? Because 26 goes into 5, like, well, 25 over 5 would be 5. So it's like, yeah, it's a little over 5, right? So then when you multiply something that's a little bigger than 5 times 2, you get something that's a little bigger than 10, right? But it's negative. So I got negative 10 and some change plus 10. Is that answer going to end up being positive or negative? Negative. I got negative 10 and then a little bit more plus 10. Well, when I add those together, I know that whatever this is going to end up being a negative number. Oh, no. Absolute value can't be negative. Now, if you don't buy that, maybe you're saying, oh, well, maybe that's just because you screwed up over here, blah, blah, blah. On your own time, figure out what negative 2 times 26 over 5 is, right? Really, it's just negative 52 over 5 plus 10, which you can call 50 over 5, right? So then you got negative 52 plus 50 is negative 2 over 5. So really, that wasn't that hard. But this would end up being negative 2 over 5 on the right side. Over here, same thing. You could do that math, but you know it's going to end up being a positive, and that can't happen. So what we end up having over here is 26 over 5. Even though we did everything right, we followed all the right steps, we did all the perfect math, 26 over 5 ended up not being a valid solution. That's what we call an extraneous solution. You gotta watch out. Those are dangerous. Angry face. Because we did everything right. And it still came up with something that wasn't a valid solution. Because x equals 26 over 5 does not actually work. Shucks.
Did you do this on purpose?
Every now and then I get fingers. So, does that mean that there is no solution? Not necessarily. Let's go check the 14/3 real quick. Let's see if I can squeeze it in over here. Alright, so here I am checking it. It was 1/2, and I'm going to do 14/3 minus 3 equals negative 2 times 14/3 plus 10. Fractions, oh my gosh, get used to them, guys. 14 over 3, you guys buy the 14 and the 2 can reduce down to 7 over 1. So really I got 7/3 minus 3. Can we write 3 as somebody over 3? How about 9? 9 over 3 is the same as 3, but now I have a common denominator. That's over here I got negative 28 over 3. You guys buy that?
Okay.
Yeah.
Yes.
Yes. Negative 28 over 3. How can I write 10 as somebody over 3? How about 30? Sure. All right, 7/3 minus 9/3 would be negative 2/3, but it's absolute value, so it turns into 2/3. What's negative 28 plus 30? 2, right? So then, since it's thirds, then, hey, holla back. We got one of them to work. So it ends up being the final answer is you say x such that x equals 14 over 3. Not 2/3. 2/3 is just what we did when we checked it. But 14/3 was actually the value of x. How's that?
We'll go over that again.
This is that right here? right, real quick. This is fractions 101. I know it's sometimes a lot of teachers they shy away from it because they know it fries kids' brains. But we got to start manning up in here, woman it up. Here we go. So you okay with how we plugged in 14 thirds? Yeah, 14 thirds was the value of x that we thought was the right answer. So 1/2 times 14 thirds. Look at the 14 over 2. That's like 7. So 14 over 2 reduces down to 7 over 1. If you don't like that, just do 14 over 6. And then reduce it. And you get 7 over 3. Alright. Over here, and then I know since I'm going to subtract them, I need a common denominator. So let's go ahead and change the 3 into somebody who's over 3. By the way, props to you for asking. So a lot of people you probably were like, I didn't get it, but I'm looking at it. So I give you props for it. So 3 is the same as 9 over 3. Now I have a common denominator, hip hip hooray. 7 minus 9 is negative 2. Absolute value, we left it positive. And 3 comes along for the ride. It's like saying 9 boxes minus 7 boxes is 2 boxes. 9 thirds minus 7 thirds is 2 thirds. Right? So we bring 3 down.
Wait, how'd you get 3 out of 1 and 3 minus 3?
Because that's what I'm saying. So like if you have 2, like if I have 5 boxes minus 2 boxes, I have 3 boxes. So 7 thirds minus 9 thirds is 2 thirds. Like the thirds just comes along. Right. So then the right side is probably a little easier. If you can follow the left side, then the right side isn't too bad. If you still have trouble with it, come catch me in the morning and I'll try to find a good website for you. I will go through it. Now, before we get out of this thing, rule number 1. When you're solving absolute value equations, how many answers can you expect there to be? 2. Does that mean there are always 2?
No.
No. What's the situation where you end up with 0 solutions? If absolute value equals a negative, right? The one solution, that extraneous thing, that always happens, or the times you need to check for it is when you have an x on the other side too. That's the only time it's going to happen. Okay, so like here you had absolute value and then you had equals something over here with an x in it. Okay? One last thing I want you to jot down in your notes before we get out of here and I give you the homework. If I were you guys, it always helps me to have steps when I'm solving absolute value equations or any type of thing. So these are what I call the steps for solving AbsVal equations. Step number 1. You need to make sure that that absolute value is by itself. So I call that isolate. You need to isolate the absolute value. Don't go splitting it up into 2 equations yet. That's step 2. Is to separate into mystery box equals the positive and mystery box equals the negative. So isolate, separate. Here's step 3. I didn't even Step 3 is solve each of your equations. And step 4, check it. Okay. Bell's going to ring in 3 seconds. On your way out the door, make sure you grab a homework. It's going to be so much fun. I know you can't wait. Keep grabbing on your way out the door. We're going to go over it. The answers are going to be on the website. So make sure that you check it before you come in. No video this time, but the answers will be there.
Ladies first.
Who's me first?